So, Mars. It's the poster child for space colonization. But what if Mars isn't the silver bullet everyone thinks it is? Or what if it's more of a dusty fixer-upper than the new space frontier paradise? My name's Brad, you're watching Hello from Space, and today we're going to take a tour of some of the other destinations in our solar system, other than Mars, that have been or still are seriously considered as potential homes for humanity. Some of these places offer genuinely surprising advantages, yet you've probably never heard of them. And others are more like long-term science fiction, but the idea here is to get beyond Mars and see what else our solar system has to offer, and what it'll take to get there, set up camp and support a sustainable human colony long-term. So, with that said, let's get into our options one by one and answer the question, if not Mars, where else? All right, let's start with a familiar face. Now, the moon is kind of like your next door neighbour's empty plot of land. Close enough to walk over to and stare at, but not exactly turnkey real estate. Still, if we're going to live anywhere off Earth in the near future, the moon is sort of a low-hanging fruit. Now, its biggest asset is distance. It's only 3 days away, so it's well within our current reach. Now, Starship, for instance, if and once fully operational, promises the ability to carry large payloads to the surface. So resupply missions could be frequent, say an emergency evacuation, if ever needed, would be fairly easily possible. Now, NASA's Artemis program, at least in theory, is attempting to lay the groundwork for a sustained human presence on our closest celestial body. Now, the moon has no atmosphere, which makes things both easier and harder. Now, easier because you don't have to deal with weather or entry drag, but harder because you've got zero protection from radiation or micrometeorites. Lunar regolith, basically crushed rock powder, could also be used to build berms or protective barriers over future habitats, but it's also incredibly fine and clingy, which means it gets into seals, lungs, and machinery. Now, temperature control is another significant challenge. Because the moon is tidally locked with Earth, meaning the same face of the moon is always facing the Earth, it doesn't spin on its own axis like the Earth does around the sun, the lunar day and night are each about 14 Earth days long. Now, this means extended periods of extremely cold temperature, down to about minus 173 degrees Celsius or about 280 degrees Fahrenheit. Now, because of this, habitats would need both high-efficiency solar collection and long-term energy storage, possibly fuel cells or small nuclear reactors, which can provide sustained power for important things like life support, as well as other significant power demands associated with a space station during the extended 14-day lunar night. But overall, our moon is the most doable. It's more of a logistics problem than a technological one. Now, if Starship can deliver, say, prefabricated modules, and we can figure out how to use lunar resources instead of having to ship everything from Earth, it could become our first real step out into the solar system. Now, on that note, it is worth mentioning, though the moon has a lot going for it as a potential staging ground for further exploration and eventually colonization of our solar system, as it pertains to SpaceX's Starship, which is currently sort of the only proposed realistic option for human spaceflight to other bodies in our solar system, there is one critical element missing, and that is carbon. Now, Mars already has the elements necessary to make methane and oxygen. In theory, once you set up a fuel production plant, you wouldn't have to take all the fuel with you for the return trip, which makes logistics a lot easier. Now, this has absolutely been part of the math for SpaceX in selecting methalox as a propellant for Starship's Raptor engines, methalox being the combination of methane and oxygen. So while the moon is rich in water ice, which can be split up into hydrogen and oxygen, the moon has extremely low amounts of carbon. Now, to make methane, which is CH4, 1 carbon atom and 4 hydrogen atoms, you obviously need carbon. Now, without carbon, you just cannot make fuel for your Starship, which means you either have to bring the fuel with you, which is highly inefficient, or bring carbon with you, which is also not particularly efficient. So if we shoot for the moon with Starship, we're more than likely just shooting for the moon and not using it as a staging ground for further exploration, at least not with a methalox-powered ship. A hydrolox-powered ship, meaning hydrogen and oxygen, would be a different story, but hydrogen also presents its own set of difficulties. Now we head all the way out to Jupiter and we arrive at Europa, an ice-covered moon that's probably hiding a liquid ocean beneath its crust. Now, Europa is one of those places that keeps planetary scientists up at night, not because it's terrifying, but because it could, in theory, be hiding alien life underneath its icy outer shell. Now, tidal forces from Jupiter keep Europa's interior warm, likely maintaining a global ocean beneath sort of 10 to 20 kilometres of surface ice. That makes it a prime target for exploration, but it's going to be a pretty brutal place to work. The biggest hurdle is going to be the radiation. Now, Europa sits smack in the middle of Jupiter's magnetic field, and the surface gets beaten with enough radiation to kill a human within minutes of exposure without serious shielding. That means any long-term human activity would likely have to go underground, or in the case of Europa, under ice. The habitats could be buried beneath the surface to avoid most of this radiation. Now, power would almost certainly need to come from nuclear sources, being that this far out from the sun, solar energy is extremely weak. And then there's the challenge of actually accessing the ocean itself. It would require cryobots, or a robot specifically designed to melt its way through the ice, or something like thermal drills capable of melting through probably dozens of kilometres of ice without getting stuck. Now, in terms of actually getting there, Starship could, with enough orbital refueling, deliver cargo sort of within Jupiter's neighbourhood, but getting from orbit down to Europa's surface and then being able to do anything actually useful there would unfortunately demand a level of infrastructure we're nowhere near at the moment. That said, the payoff, possibly discovering alien life, is enough to keep Europa on the radar for the moment. Now we get to Titan, Saturn's largest moon, which is one of the sort of strangest but most promising bodies in our solar system. Now, what makes it so promising? Well, Titan has lakes, rivers, rain, even a thick nitrogen atmosphere, but before you get too excited, it's also cold, like really cold, cold enough to freeze propane solid permanently. Now, the surface of Titan sits at about minus 180 degrees or minus 292 Fahrenheit. So you wouldn't just need warm clothes, you'd need a heating element in your spacesuit just to stay functional. But different to Europa, Titan's thick atmosphere, it's about 50% thicker than Earth's, is a huge advantage. It shields against radiation, which is good because radiation equals much badness if you want to be alive, but it's also dense enough that humans could literally fly with simple powered wings. We're talking a backyard glider powered by your arms, full Icarus style flying around without the melting and the falling and the dying. Now, Titan's atmosphere is also rich in hydrocarbons. Its surface features massive lakes of methane and ethane. This makes it a chemical goldmine. You could easily produce an abundance of methane on site, great for return missions, power generation, even fueling vehicles, because methane, also known as natural gas, is quite capable of running combustion engines. Now, you'd still need oxygen brought in or extracted from ice, and life support would still be entirely artificial, as with all the other options we've discussed. But there's a lot of pros going for Titan. Now, building habitats here would obviously mean insulating against that extreme cold, as well as maintaining pressure, and dealing with a sky that never really sees the sun. Now, solar power obviously also isn't really viable because of a distance from the sun. Again, nuclear is the much better bet. Now, with Starship delivering modules and reactors, a long-term outpost definitely isn't out of the question. Titan might not be warm or easy, but it definitely has a lot of potential. Next up is Ceres, the largest object in the asteroid belt, and a bit of a wild card. It's technically a dwarf planet, and it sits right between Mars and Jupiter, which actually makes it a great potential logistics hub for deep space operations. Now, Ceres has really low gravity, about 3% of Earth's, which actually makes landing and launching extremely energy efficient. It also makes it a good candidate for robotic mining and construction. It's thought to contain water ice beneath the surface, maybe even brine pockets, which are essentially pockets of really salty water. Now, the cons. It's cold, which is becoming a bit of a recurring theme. It also has no atmosphere and gets very little sunlight. Now, this means that habitats would need to be fully pressurized and sealed with internal life support, probably nuclear energy to keep things running as well. Now, radiation is also a concern, though not as bad as on Europa. You'd probably want to go underground and build thick-walled domes for protection. Now, with Starship, we could theoretically deliver equipment here if we had in-orbit refueling and some serious logistical planning. It's not glamorous, but Ceres could be an ideal place to practice off-world construction in a relatively stable, low-risk environment. Now, as it pertains to asteroid mining on Ceres, most of what we know about Ceres' composition is data collected by NASA's Dawn mission. Now, this probe orbited a dwarf planet from 2015 to 2018 and found little to no evidence of rare earth minerals, which would make deep space mining attractive. But this is entirely based on the results given by a single probe, so take these results with a sip of brine. Kalisto doesn't get as much attention as Europa or Ganymede, but it might actually be the most practical Jovian moon for human settlement. Jovian, by the way, means related to Jupiter. Now, it's the outermost of the Galilean moons, which are Io, Europa, Ganymede, and obviously Kalisto, all discovered by, you guessed it, Mr. Galileo himself. Now, Kalisto sits far enough away from Jupiter to be outside the worst of its radiation belts. Now, much like Europa, Kalisto is an icy body, and it may also have a subsurface ocean. It's just not as certain. Now, the big win here is stability. Now, Kalisto is geologically quiet, which makes construction obviously a lot easier. You're also dealing with a less hostile radiation environment, so you wouldn't need the same degree of shielding. That radiation shielding generally tends to be quite heavy. With Kalisto being a long way away, this is a huge plus as it means we have more payload weight to take other useful stuff with us. Now, of course, it's still really cold and, as I mentioned, a long way from Earth. So solar power, much like with the other deep space options we've already covered, is also very, very weak. So nuclear reactors would have to handle the energy needs. Now, getting there would most likely require long-term missions, and surface operations would have to be almost entirely self-contained. But if you wanted a long-term science base or a logistics hub in the Jupiter system, Kalisto might be the best place to start. It's sort of far enough to be safe, but close enough to be useful. Now finally, let's talk about asteroid bases. Now, this isn't about terraforming or even traditional colonization, it's more about infrastructure. Now, think of this like setting up service stations or mining outposts along the highways of space. Now, 16 Psyche, for example, it's a metal-rich asteroid that current data suggest might be the exposed core of a failed planet. Now, it's believed to contain vast quantities of iron and nickel, possibly even some precious metals. Now, if we're serious about building in space, Psyche and asteroids like it could quite possibly be the raw material sources. Now, life on an asteroid would be nothing like life on Earth. There's basically no gravity to speak of, so you'd need sort of rotating habitats or some form of artificial gravity workaround. Every aspect of life support would be artificial: air, water, food, temperature. Now, the plus side though, you can dig and build shielded habitats inside the asteroid itself. And since there's no atmosphere, you can operate machinery without worrying about weather or corrosion. Now, Starship, again with orbital refueling, could potentially deliver mining equipment, prefabricated modules, and even personnel. Now, once there's infrastructure in place, asteroid bases could support larger space operations, like for instance, missions deeper into the outer solar system, to the moons of Saturn and Jupiter and other places that we've already discussed. Now, the other factor here is spaceflight hardware is expensive. If we're able to successfully mine asteroids, this has the potential to bring in large sums of revenue, funding more spaceflight hardware, more spaceflight, and even more space exploration. It would also potentially make technological development on Earth cheaper with a more abundant supply of the raw materials required to make more sophisticated technology and hardware. So, is Mars the best option? In many ways, yes. It's close, it's got enough gravity, just enough atmosphere, and a fairly manageable environment. Difficult but not hostile. But as we've seen, it's far from the only game in town. Now, the moon is close and quite doable. Europa and Titan both offer significant scientific and strategic advantages. Ceres and Kalisto are quiet, stable stepping stones. And asteroid bases, that might be where the real space economy actually begins. With vehicles like Starship, nuclear reactors, and robotic infrastructure on the horizon, the solar system is starting to look a lot more accessible. Now, it won't be easy, but colonizing space was never going to be easy. What matters is that we're starting to see a path. Now, if you liked or found this video interesting, go ahead and click on one of my other videos that should be popping up on the screen. And if you like those and want to see more, I invite you to go ahead and hit that sub button. I'm trying to get these videos out every 2 weeks. I'm doing my best, I promise. But as you can hopefully see from some of the upgrades I've done around here recently, I have some big plans and some awesome content in the works, and you don't want to miss out on that. It also means you get to be part of something brand new. Anyway, that's it from me. Thanks for watching. Have an awesome week, and I'll see you guys next time.